Welcome back, students. In this video, we're going to do Module 5, Topic 2, that's congruent triangles. The standards for this topic, GR 1.3, prove relationships and theorems about triangles, solve mathematical and real-world problems involving postulates, relationships, and theorems of triangles. We also have standards GR 1.6, that solve mathematical and real-world problems involving congruence or similarity in two-dimensional figures. And we also have GR 2.6, apply rigid transformations to map one figure onto another to justify that the two figures are congruent. The objective for this topic, you guys are going to use congruence criteria and the third angles theorem to solve problems. On page 6 of the Module 5 topic, we have the warm-up. I'm going to pause here. Please work the warm-up. We've got two problems there. These just need to find a couple of angles. I'll wait 3 seconds and then I will go ahead after you're done, see how you did. All right, warm up, page 6. Find the measure of angles 1 and 2. So we're finding 1 and 2. So notice we have a box. You guys know what that is by now. I'm not going to keep on, except, it's a right angle. Anyway. So, to find the measure of angle 1, we're going to take, since we know a triangle is 180 degrees, we're going to subtract 90 and 26 from 180 to get the measure of angle 1. So, measure of angle 1 equals 180 minus 90 minus 26. All right, so 180 minus 90 is 90. 90 minus 26 is 64. So, the measure of angle 1 is 64 degrees. Now 2 we know is an exterior angle, so angle 1 and angle C here are both the remote interior. So for the measure of angle 2, we're just going to go 64 degrees plus 26 degrees because the measure of the exterior angle is those. But wait, Mr. Whitlock, these right here are that's a linear pair. If this guy is 90, so is angle 2. Well, 64 plus 26 equals 90. So we're both right. But yes, you could have just said, angle 2 is a linear pair with a 90-degree angle, so it has to be 90, or do it like that. You still had to find 1. Although to find 1, if you knew this was 90, just 90 minus 26 would have given you that. 90 minus 26 is 64. Isn't math great? All right, number 2. Find the measure of angle 1 and the measure of angle 2. And the measure of angle 3. So 1, 2, and 3. All of these are exterior angles. So let's start with what we know. We know that 1 is going to be this plus this. So the measure of angle 1 is 28 plus 42. So the measure of angle 1 is 70. Okay. All right, so let's see, if we wanted the exterior here, it would be this plus this. So, and the exterior here would be this plus this. So we got a couple of things we can do. Notice over here, if we cover up on something that doesn't happen. So if we cover up this line, okay, angle 2 and this 28 are a linear pair. I'm going to highlight them for you. Linear pair. So that means that the measure of angle 2 is 180 minus 28. Measure of angle 2 is going to be 152. All right, now to get 3, notice here, and this is where I've been telling you guys we're going to start talking about those rules. So notice angle 1 and this blank angle are a linear pair. So if angle 1 is 70, this angle right here is 180 minus 70, or 110 degrees. Hopefully, make it a little easier for you guys to see it. 110 degrees. So, just to go back a second, angle 2, we said it was 152. Well, what's 110 plus 42? That's 152. So, another way of checking our work. But these two are linear pair. And so now 3 is going to be these two. So, the measure of angle 3 is 110 plus 28, which is 138 degrees. We did this today in class, and we did it a little different, so I'll know when I check you guys' packets, I'll know whether you watched the video or if you did it in class. Okay. Anyway, that takes care of the bell ringer. Again, we're on page 6. We're going to scoot down, start talking about the congruent triangles. Give me 1 second. Write the vocabulary in here. Second. Sorry, guys. Okay. Corresponding parts of congruent triangles are congruent. It says and, but it's are. So, the principle of superposition states that two figures are congruent if and only if there is a rigid transformation or series of rigid transformations that maps one figure exactly onto another. Recall that congruent figures have exactly the same shape and size. In two congruent polygons, and remember a polygon is 3 sides or more, so a triangle is a polygon as well. So in two congruent polygons, all the parts of one polygon are congruent to the corresponding parts or matching parts of the other polygon. These corresponding parts include corresponding angles and corresponding sides. Key concept, congruent triangles. Two triangles are congruent if and only if their corresponding parts are congruent. So for triangles, we say corresponding parts of congruent triangles are congruent, or CPCTC. We're going to use CPCTC a lot with proof, so I've already written it on the board. Please commit this to memory. CPCTC. Corresponding parts of congruent triangles are congruent. Because we're going to prove triangles congruent, and we're going to have other parts left, but once we prove they're congruent, the other parts are congruent as well. That's what this is telling us. So let's scoot down here just a hair. Okay. All right, so at the bottom here, when we state triangle congruency, the order of the letters in the names of the triangles are extremely important. How can this congruency be stated? So you guys, I've talked about colored pencils all year. As a matter of fact, I'm going to pick up some more tomorrow because we don't have enough. So when we go through here and we mark congruency, I like to, if it's one arc or one tick, they make these the same color. So we have one mark here. These are both blue. These two sides are corresponding now. We're going to keep going here. We have, I'm going to make these like colors, one of each in the angle and one on the side here. Let's see. So those two, they're orange. Whoops. 3 is going to be green. Also going to have a green 2. I'll do the other one in red because I have just another green. So this will be 3 reds. Okay. So these colors, hopefully, just put a little more light. So, yeah, how can this congruency be stated? So A, B, C, that's how they gave it to us. A was first. Notice A has one blue arc. So A and D, those are corresponding. Notice B has the 2 green. F has the 2 green. So F and B correspond. C has the 3 red. So does E. So those correspond. So let's look at 2 letters together. AB. So this line has 2 orange. DF. DF has 2 orange. Hey, that looks good. Okay. BC. BC has 1 blue. FE. FE has 1 blue. All right. Then you say CA. CA has 3 green. ED. ED has 3 green. So check, check, and check. That's how we do that. So going forward, we give it back exactly how they gave it. They gave it A, then B, then C. We went and looked and saw what corresponded. D, then F, then E. So don't just assume because it's A, B, C, it's going to be D, E, F. We have to look at this and pay close attention to this. All right, that's page 6. Let's flip over to page 7. Whoops. Went backwards. I went to 5. So here's page 7. Excuse me. All right, page 7. Top of the page, we'll have a number, so we're just gonna, like it's just another example here. So it says if triangle JKL is congruent to triangle COT, finish the following congruent statements and mark corresponding congruent sides and corresponding congruent angles. All right, so this will be a little different. We don't have the marks already, but they gave us the answers. J, C, those are the first. So J, C. Look up here and find it. Angle J is congruent to angle C. All right, so the next angle was K. K. The next angle was O. O. Just 2. My mess up. Just 2. So K and O. K, angle O. And then lastly, T. Well, L, T. L, T. T, angle L. Okay, now let's go to the sides. JK. JK. So orange then green. Orange then green. CO. JK, CO. Also notice JK, first 2 letters, CO. CT. 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 Orange then blue. CT. JL. Orange then blue. So CT. JL. All right, KL. KL is green then blue. Green then blue here is OT. So we line those up. If you guys can get that. Oh, let me do this. Sorry. JK, CO. JL, CT. KL, OT. Sorry, 2 blues there together. I usually try to keep that pretty separate, but I'm limited on colors this evening. All right, let's scoot up. Number 3 and number 4, again, still on page 7. Is ABC and XYZ congruent? Justify your answer using rigid transformations. So we are going to map our points here. A is at -4, +5. How did you count that so quickly? I've already got it. B is -1, 2, 3, 4, 5, +1. -5, +1. C is -1, -2. Sorry, -2, -1. -2, -1. X over here is at 1, -2. Y is at 0, 2. And then Z is at 1, 8, 3, 1, 2, 3, 4. All right, so notice, so this says A, B, C, X, Y, Z. So B and Y, A and X, C and Z. Notice these are, we're going to have to flip that triangle. So to get it flipped, we're going to reflect it in the x-axis because, just watch. So let's just try to reflect it in the x-axis. Sometimes you have to try a couple of things. You guys know we did this in class. I told you to skip it because I had the right answer, but I did it backwards, and it took me a few minutes to redirect my brain to get it right. So I'm going to show you guys now. So we're going to reflect it in the x-axis first. So A is at -4, 5. And when we reflect in the x-axis, to reflect in the x-axis, your x comma y is going to be x comma -y. We multiply the y by -1. So your -4, 5 is going to be -4 stays the same, but because we're multiplying y by -1, 5 is going to become -5. Okay, so our new point, we can draw these in green down here, -4, so -1, 2, 3, 4, -5, 1, 2, 3, 4. We got to draw another line here because this is our point. It's going a little bit beyond our chart there. Okay, let's do B. Try not to make this too messy. I'm not going to do all 3 points, but if I get the 2, I hope you guys will believe me. So B is -5, +1. So X, so -5 stays the same. -Y, so Y was 1, -Y is -1. Let's go. So we have -5. So we're still out here at -5, but we're at -1. It's going to be hard to draw that now. Actually, let me look at my numbers again. Hold on. Would that be -5, -1? Yeah, that's right. Okay. Actually, I'm just going to do all 3 because if I run out of room, we'll have to right below. All right, so C is -2, -1. So your X stays -2, but our -1 is going to be +1. So C is going to be, whoops, -1, 2, +1. So we reflected over. Now we're here. It's not a very good drawing. I apologize. So now how do we get it from here to here? Use this blue. So this was C prime right here. It flips over. So to get C and Z are the same. So we're going to go 1, 2, 3, 4, 5 to the right. So that's +5. So we're translating +5. That's your direction. And this is your magnitude, how we got to go up. 1, 2, 3. So we went up 3. Well, let's just test it here with A. A goes with X. So it's 1, 2, 3, 4, 5. I'm below, but you see I'm lining up. So it was 5 over. Now from here, we're 1 beyond that. So we're going to go 1, 2, 3. So 3 up. You could do it with 2. You could do it with the third. But so you see, that's where it lines us up. It puts us right here at the end. Go. So the answer here, we reflected in the x-axis, and then we translated +5, +3. All right, number 4 is a you do. I'm going to ask you to pause the video here. Please try to work that problem. Unpause the video and see how you do. I'm going to wait 3 seconds. All right, number 4 is triangle LMN congruent to PQR. Justify your answer using rigid transformations. So again, L and P are together. Well, then M and Q, and then N and R. Okay. So let's get our points. I'm just going to do 1 here. We're going to do P and L. P is -1, 2, 3, 4. So it's -4, -1. L is +1, +1, 2, 3, 4. So 1, 4. So we start off with L at 1, 4, and we end up at P, -4, -1. Well, our X goes from the front to the back and becomes negative, so X, Y. So we got -X in the back. If y'all can see that. Let me write it. Let me just do it down here. So X, Y. We know that the X is negative in the back, but also the Y moves to the front and becomes negative. So X, Y becomes -Y, -X. And that's a coordinate rule for the line Y equals -X. We talked about in class the line that goes from the bottom left to the top right. Well, this one goes from the bottom right to the top left. That's what this line is. It's Y equals -X. So that's what our transformation was to get. We check the others. Q is at -4, -1, 2, 3. M is at +4, +1, 2, 3, 4. Wait. Yeah. No, +3. Yeah. 1, 2, 3, 4. no, shoot, 1, 2, 3, then 1, 2, 3, 4. So it went from -4, -3 to +4, +3. Before I confuse us all, I'm going to move on. Okay, bottom of page 7. Let me just get this where you guys can see the whole thing, because we're going to be working down here. Go ahead and draw a couple of things. And then I'm going to explain a couple of things. All right, so the third angles theorem. Theorem 5.3, third angles theorem. If two angles of one triangle are congruent to two angles of a second triangle, then the third of angles of both triangles have to be congruent. So it says if C and K and B and J, that means A and L has to be. And let me show you a little mathematical thing. So let's just say that C is 60 degrees. So is K. They're congruent. Let's say J, or let's say B is 70 degrees. J is 70 degrees. So 180 minus 70. So 170 and 60 make 130. 180 minus 70 minus 60 equals 50. So that means this guy has to be 50. Well, if you do the math, it's the same thing. This guy has to be 50. So the third has to be, and it's a mathematical thing. I mean, yes, it's a geometry rule, but it's a geometry rule because mathematically, if two equal, if you have three things that equal one total, if the first two things are equal to each other, the third has to be. All right, theorem 5.4, properties of triangle congruence. So just like we talked about first with numbers, then with line segments, now we're talking about triangles. So triangle ABC is congruent to itself, and that's reflexive. If you look in the mirror, you see yourself. And also like 2 is equal to 2. Symmetric. If ABC is equal to EFG, then EFG is equal to ABC. Or it's like if 2 plus 1 equals 3, then 1 plus 2 equals 3. And then they do it with 3 here, transitive. So if ABC is equal to EFG, and EFG is equal to JKL, then ABC is equal to JKL. So let's say ABC is 2 plus 1. Say EFG is 1 plus 2. Let's say, so 1 plus 2. Let's say JKL is 3 plus 0. So then 2 plus 1 has to equal 3 plus 0. I know that's very rudimentary, but see, this is equal to this is equal to that. Hopefully that helps you get the idea. All right, flip over to page 8. Page 9 will be the independent practice for this topic. Excuse me, there's page 9. 4 problems. But first, page 8. So, move this light. There we go. All right, how about page 8? If RSV is congruent to TVS, solve for the missing variables. So RT S V. Wait a minute. S. Oh yeah, because they both. Anyway, that didn't really work out the way I wanted it to. But we'll use this here. So RS TV. Showing you how we're going to solve this. So to start off, solve y, it's going to be 2y minus 1 is equal to 24 because those are congruent, so they're also equal. So we add 1 to both sides to isolate y. 2y equals 25, divide both sides by 2, and y is going to equal 12.5. Sometimes you have decimals, sometimes you don't. All right, so notice that R and T are corresponding, so they are also congruent here because the triangles are congruent. So if we solve this angle, we get x. We have 90-degree angle here and a 78, so to get the measure of angle R, it's going to be 180 minus 90 minus 78. All right, you do the math on those, and the measure of angle R equals 12. Well, because the measure of angle R is equal to the measure of angle T, that makes X equal 12, because we just substituted T equaled X, R equaled 12, because we subtracted it out there. That makes sense? I hope so. If not, ask me in class or send me a message. All right, number 2 is a you do. Please pause here. Work this problem. I'm going to wait 3 seconds. After you're done, unpause, see how you do. All right, number 2. If ABC is congruent to EDC, solve for the missing variables. So A is up here with a box. So is E. That's good because they correspond. They're also congruent. Notice, so B and D would correspond. And then C is the angle for both of these. Notice this is also the vertical angle. So those are congruent anyway. If we were doing a proof, we would have had those two angles. We would have been told they're congruent, and our reason would have been vertical angle. But anyway, so for now, because A and B and E and D are the corresponding angles, that means AB and ED are corresponding sides. So to solve for X, we're going to put 3X minus 10 equal to 20, because that's what that means this line segment is 20 yards. This one is 3x minus 10, but they're congruent, so we put them equal to each other. Add 10 to both sides. You get 3x equals 30. Divide both sides by 3. X is equal to 10. All right, so now we have y. Okay, see, these angles are congruent. These angles are congruent. So to get c, which is also y, so y is going to equal 180 minus the 90 minus, this is 36.87. When you do the math there, y is going to equal 53.13. See how this angle, so 180 for the whole, minus 90, minus 36.87, and both sides here equal 53.13. All right, bottom of page 8. This is the end of lesson 2. Let me get this all on the screen if I can at the same time. I want the word bank too. So yeah, bottom of page 8, number 3 on the left. Given, excuse me, J is congruent to P. JK is congruent to PM. Sorry, we just used the two articles there. It was already there. JL is congruent to PL. And L bisects KM. So in class, I asked you guys, the ones that were there today, and I'll ask you watching the video, so what does it mean when it says L bisects KM? Well, hopefully you've been paying attention. You know that bisects means it cuts it into equal pieces. So that's going to put KL congruent to LM because of that right there, and we're going to see that down here below, but we've already got it marked. So number 1 is our given. This is where all of our statements up here. The reason was given. Number 2 says JKL, so JLK and PLM are congruent. Let's do this. So these two are congruent. So we've got some reasons here. We got third angles. Well, this is the first angle we're talking about, so that's not it. Reflexive, well, reflexive, it means something's congruent to itself. It's got to be vertical angles, and that's correct. And you notice, so this is two intersecting lines. These angles are side by side. They're congruent. These angles are on top of each other. They would be congruent too because they're vertical angles. All right, number 3 says LK is congruent to LM. Definition of a segment bisector. There you go. So that's why those two are congruent. So number 4 says that K is congruent to M. So we know that J and P are congruent because it told us. We know that JKL and PLM are congruent because they're vertical angles. So that's one angle, two angle. It's got to be third angles theorem, because that's the third angle. So it was, in case y'all were wondering. And that's the third angles theorem, or the third angle theorem, depending on who you ask. Okay, number 4 on the right is the last you do. Please pause here. Try this proof. I'll wait 3 seconds, then let's see how you did. All right, number 4. Our givens are up here. So it says that WXZ, so this side, is congruent to YXZ, this side. Okay? And that XZW, this side, is congruent to XZY, this side. Let's just do this. WX is congruent to YX, and that YZ is congruent to, WZ is congruent to YZ. Okay, so there's everything marked. And that's the first thing they tell us, and it's given, because it was given. Number 2 says that XZ is congruent to XZ. Well, heck, man, that's the same thing. Well, yeah. And XZ is congruent to XZ, because it's the same thing. If you look in the mirror, you see yourself. That's reflexive. Now, notice, and I should have pointed this out before, but so this line, XZ, the reason it's congruent to itself, it's the right side of the left triangle and the left side of the right triangle. This line belongs to both triangles. So we need it to be congruent to itself, because that's a side of that triangle that's of those 2 triangles that are congruent, because it's the same thing. It connects them. All right, so next it says XWZ and XYZ are congruent. So we're talking about, so we got an angle here, so we're talking about a third angle. So third angle theorem tells us that those 2 angles are congruent. Let's see. So there you go. All right. If you have any questions, please let me know in class. Hope you got something out of this video. Until next time, have a good night.